This is the homework solution for chapter 26, homework problem number 17, asking us what is the net electric force on charge A in this corresponding figure. And in order to find the net electrical force on charge A right here, we first have to identify all of the forces acting on A. And first off, we have the force on charge A from charge B directed upwards, since the two negative charges repel each other. So the force of B on A. And we also have the force on A from charge C directed downward, since the two opposite charges attract each other. F of C on A. And so then we want to find out the values of these forces in order to get the net electrical force. So the force of B on A is equal to, using Coulomb's law, constant K times the absolute value of the charge of A multiplied by the absolute value of the charge of B divided by the distance between the two charges squared, which equals 9.0 times 10 to the 9th Newton meters squared divided by Coulomb squared. Multiplied by 1.0 times 10 to the negative 9th coulombs times 2.0 times 10 to the negative 9th coulombs. All divided by 2.0 centimeters squared, which is 0.020 meters squared. And then this is equal to 4.5 times 10 to the negative 5th newtons. And so the force vector for B on A is equal to 4.5 times 10 to the negative 5th newtons in the upwards direction. And then we need to find the force of C on A. This is equal to constant K times the absolute value of the charge of A multiplied by the absolute value of the charge of C, all divided by the distance between them squared, which is equal to 9 times 10 to the 9th meters squared over Coulomb squared times 1.0 times 10 to the negative 9th coulombs times 2.0 times 10 to the negative 9th coulombs, all divided by 3 centimeters squared. And then this is equal to 2.0 times 10 to the negative 5th newtons, and which means the force vector of C on A is equal to 2.0 times 10 to the negative 5th newtons in the downwards direction. Looking at our vectors, And then the net electric force on charge A be equal to F of B on A plus F of C on A, which is equal to 4.5 times 10 to the negative fifth newtons. And we are going to subtract the force vector we're going to flip the sign here to a minus sign because it's in the downwards direction. From our vectors, it's a negative direction. The negative fifth newtons in the upwards direction. And then that's all equal to 2.5 times 10 to the negative fifth newtons in the upwards direction. And that is the answer.